Hi, this is Finite Math Modeling 2.5, which is for all practical purposes 3.4, 3.5, independent task scheduling and bin packing methods. And then you also will have two other videos, one which will go through this that comes from the authors of the book, and then also we'll do some vertex coloring. So if we have our example from what we had in our previous sections, we had the digraph all set out with different tasks. These were the tasks. What if I remove all these prerequisites? In other words, we make them independent. So it doesn't matter when I start A, when I start C, when I start F. I can start any one of these at any time. And so then we have a little bit different situation, and then we want to do independent task scheduling. And so what we say is that maybe we have 3 machines. It doesn't matter how many machines we have, but we're given a fixed amount of machines to start with. So 1, 2, and 3. If we want to schedule these things, we can just take them in the order that they're given. Say, for instance, a customer brings in something that we need to do. It takes 2 hours. Someone else 4 hours, so on. We just take them as we can get them in, first out. So what we want to do then is try to schedule this. So machine 1, what we'll do is just start with this first item. And that first item is 2, so we'll schedule that on that one. Then the next item, we'll go to the next machine and schedule that. Whatever's open, we're going to schedule. So then the next item would be the 5. And so this is how we're going to do this. And so then the 3, where would that go? Well, I think it's going to go here because that's the earliest start time that we can have someplace. So we put that there. And then the 2, earliest start time would be here. And then the 6, earliest start time would be here. Oh, why did I put it there? Well, we place it on the earliest number or the lowest numbered machine first. And since these two are tied, we put it on machine 1. And then I have my next one, which is the 7. That was the earliest start time, and so we go out to here. And then the 3, well, I'm going to put it here because that machine is available for that. Okay, so that's how we would schedule it out. How much time does this take? Well, if we look at this, if we counted this all up, we could go out to 12. Okay, and so that's how long this process would take, and we have some downtime on this machine and downtime on this machine. Can we get better? Well, what if we list them in descending order first? And so I took all these and I put them in descending order. And so when I place them, I'm going to place the 7 first and so on down the line. Now, in theory, this should always work better. It doesn't always work in practice that way. For our example, I think it does work better, but let's see. So if I do machine 1, I'm going to schedule the 7. And so there we go. And then the 6 on machine 2, and then the 5 on machine 3. Going on, then I'm going to schedule not here, but down here, because that's the first one available. So then I do the 4 would be after that. Then the 3 would be after that. And then another 3, and then my 2 2s. Those just go here and here. Now, if you notice, how long does this take to complete? Well, that would then be 11. Where's my 11? There it is. Okay, so that would take 11 time units or whatever it might be to finish. Okay, so with this, we just put everything on when we can. Pretty much, that's what we're doing. Okay, there might be other methods too, but this is one method that we do look at. Now let's move on to bin packing. So with bin packing, we can place items without prerequisites as well. But the size of our bin is fixed. And so it can only fit a certain amount of items in there, and we can't overflow on that. So think about Amazon, and they need to pack, for instance, 4 items to send to one place. How do they do that? And how much space do they have in a box? And then we don't want to overflow it, and then they put air packs in there, all those kinds of things. So how do we place these into a box to minimize the space and make it easy to ship? So let's take our same example, numbers, but now we want to put them into fixed bins or boxes. So this would be of size 7. So that's the size that I have for this information. So first of all, we want to say is what is the minimum number of boxes that we have for our goal? So if we do this and take all these numbers and add them up, we are going to get 32. And then we're going to do what with that? Well, we want to find out what our goal is. So their size is 7 items that we can put into that. And so we're going to go 32 divided by 7, which gives me 4 and remainder 4. Well, these will just be left over. So really I'm going to need 5 boxes. Okay, so we want to go ahead and place these in each one of these. So one is the next fit algorithm. The next fit algorithm is that I'm going to take these things that come off the assembly line as they come. I'm going to put them in a box, fill it up as much as I can. I'm going to send that box off. So that's one way to do this. So if I set this up, my first one is 2. So I'm going to place 2 in that box, and my next one's 4. Now the next item is 5. Well, it can't fit in here anymore, so I'm going to take this box 1, send it away. It's done. Even if we have a lot of extra room, yep, it's done. So let's go to the next one, and so I'm going to place a 5 and put a 5 in there, and then can I put a 3? The answer is no, so I'm going to send this box as well. And then the next one would be placing the 3. Oh, I can place a 2 in here as well, but I can't place the 6. I'm going to send this box away. I can't put anything else in it. And then the next one is going to be a 6. Can't put anything else in it. Send it away. Can't put anything else in it. Send it away. And then I have my 6 box. So we weren't that efficient with this because our goal was 5 boxes, but we ended up with 6 under this next fit algorithm. Now, why do we make these algorithms? Well, they need to solve these problems using computers. So the algorithm is useful in programming computers to try to fit these things all together so that we make it more efficient if we can. We didn't make it that efficient though. So maybe we have another algorithm. Let's look at the next one. So the first fit algorithm is a little bit different. What's going to happen is that we're going to go ahead and take this 2, place it in box 1, and then take this 4, place it in box 1. If we can't place something here in box 1, we're just going to place it in box 2. However, the next item, whatever comes up, we're going to try to fit it in box 1 again. So it's like all these boxes are open, and I'm going to try to start here, move on down the line until I can fit that item in. So let's place these items in. So if I take this 2, I go to the first box, and I go ahead and put it in. So if I put it in there, there it is. And then so then if I put in the 4 I can place in this first box, so I'm going to go ahead and do that. Now the 5 I can't, so I got to go to box 2, place that in. That's pretty obvious. The 3 I can't fit in this box or this box, so I start here, go here, can't, now I can. So I'm going to place it there. The 2, I'm going to start here, cannot. Now I can put it in here, so I'm going to put E into here. So that's where I put it. And then F, which is 6, can't fit here, so I'm going to have to go here. I already checked those are already full, so I'm going to go all the way over to 4. 7, can't fit in any of those, so I'm all the way over here. Now what about the 3? Well, before we might have had to put it in the next open box because we shipped these, but not in the first fit. We're going to check here, nope. Check here, nope. Check, yes, I can put it into box 3. And now I can send off all these things. And look at that. Did I reach my goal? Yes, that was my goal of 5 boxes. So I was able to do that under this algorithm. Sometimes this algorithm is better than the next fit algorithm, and sometimes it's not. It's just what we do. And so these are heuristic methods that try to be as efficient as possible. But there's so many different permutations to try to fit these in. We just have to use one method that would be easiest to program and get in there. So let's try the worst fit algorithm. What happens with this one is that you're going to open up a box. And so if you need to place something, you're going to open up a new box. And then you're going to place an item into the box that has the least amount of stuff. So let's see how this works. So if I place the 2, I'm going to open up the first box, and I'm going to go ahead and place in the 2. And then I can take the 4 and put it in here because this box is already open. So I'm going to put it there. Then I'm going to place the 5. The 5 will go into the next box because it won't fit here. And so now I have 2 open boxes. Well, the next one is a 3. Well, 3 doesn't fit here, it doesn't fit here, so I got to open up another box. And so this is where the algorithm kind of comes into play. So you see this one with the 2. The 2 can either go here or it can go in here. Well, which one has the least amount of stuff? Well, it's box 3. And so we're going to actually place it into box 3 here as such. And so this one kind of makes it so that all the boxes are somewhat, I guess, more even, maybe not, but you take it and place it in the box that has the most open space that's already been opened. So now these have 2, 2, 1. The 6 I can't place there, so that's going to have to go into box 4. 7 similarly will go box 5. Now the 3. Well, the 3 I can't place anywhere, and so I have to go place that in box 6. And so I put it there. What if this 3 was actually a 2? What would happen? Well, I could place it here or I could place it here. Usually we do it in the lowest number box, so we would have placed it here just for convenience and consistency. That would be the algorithm that would find it. Okay. Now, decreasing times, I think that I'm going to stop the video here. But with the video, now what we can do is this example, next fit decreasing, first fit decreasing, worst fit decreasing. And so what happens is that if I have this tour company and minibuses that can hold 8 tourists each, what if we have groups that have to stick together of these different sizes are booked for next Tuesday? How many minibuses are needed for transport? Well, we're going to do the same thing that we did above, except for now we're going to group all these things in decreasing order. So I place this all in decreasing order, and so that will just help me. And so if it's next fit decreasing, I'm just put in decreasing order, that's all. Then you go ahead and do the same methods that we did above. So I'm going to let you try those. But what's our goal again here? So if I try this, this is a total of 37 if I did my arithmetic right. And then 37 divided by 8, because each van holds 8. My remainder is going to be 4, remainder 5. And so we're going to round up to 5 buses. And so that's what we're going to need. Okay, so I hope that you can try this and bring this to class, and then we'll talk about it when you do get there. All right, I hope you enjoyed this. Take care. We still got a couple more videos for you. Might be a little long, but that's the way it is today. Take care. Bye.